attended so far and the people that will be trickling in. So yeah, welcome to Python Live, brought to you by Amicus Recruitment. For those of you who don't know who we are, Amicus are a specialist IT recruitment agency with networks across the US and Europe. My name is Jordan Hayward, and I'll be your host today, and I'm joined by the return of Richard Everts, a seasoned software engineer and founder of BestieBot, who are a small engineering consultancy. Now, before I hand over to Richard, I just wanted to let everyone know that the session will be run in the form of a live Q&A. So if you do have questions throughout, please stick them in the Q&A tab at the bottom of your screen. And both myself and Richard will get to them as soon as we can. But enough from me. Richard, welcome back.
Great to be back. Thanks for having me, Jordan.
No worries, no worries. I'll let you take away.
All right. Well, let me go ahead and share my screen, and then we'll get started here.
Perfect.
All right. So we got our presentation going. All right. Well, thanks for coming out, everybody. It's great to be back here, and I'm excited to talk to you today about the generative Simulacra agents. And we're going to look a little bit at the Python code behind the 2023 paper of the year. My name is Richard Everts. Many of you know me. My contact information is there. You can find me at my email. You can also find me at BestieBot, rich@bestiebot.com. You can also find me on X, where most of the people who work in the AI space are still found. So just follow me at Rich_Everts, and I'd love to see you there and join the conversation. So let's talk a little bit about what is going on with all of the Simulacra agents. Many of you saw this image and probably wondering, are we building video games? What's going on exactly? Well, first we got to kind of clear up what is an agent and what does that mean in the space today. So we have a couple of things that you may have heard about. AutoGPT came out. They have their own conferences now. It's one of the fastest growing GitHub repos in history. And they allow you to create these individual AI people that can work on a specific task. And then maybe a better way to explain it is ChatDev came out later on. And this particular tool allows you to arrange for groups of individuals to tackle a problem. So you create these separate individuals. In this particular example, you have someone designing, a group coding, a group testing, a group documenting. You give them an overall task and you let the AI go loose on solving that itself. And it'll go through and using these individual identities or agents, it'll work through the problem for you. And so you kind of use what's known as swarm intelligence. So you get a bunch of different agents to work together and swarm together to solve an issue. Lindy is another one that they just came out. I saw this announcement a couple of weeks ago on X, where you can create your own AI employees, and it's no code and all this stuff. So a lot of things are moving in this direction of using agents, individual AIs. Now, what are we talking about here? So we're talking about generative agents. This was the paper of the year in 2023 by many, many groups, Interactive Simulacra of Human Behavior. And we have this little town, Smallville, essentially, like a little the Ville, if you want to get the exact words. And you have a couple of agents. They had 25 in this example, and they live here. And they run the simulation over a period of time and check to see what the interactions are like. And it was very interesting because you had a lot of cool stuff happen. You had this huge Valentine's Day party that someone had it as their purpose as an agent to throw this party. And then they found all these people in their town to show up at the party, and they weren't programmed to do so. It just happened through the emergent behavior. And you had a lot of other cool things happen. You have a lot of people studying for school and other goals and events and stuff that happened. And it was a real watershed moment in the LLM space because it was a new way of using these LLMs. And yeah, so let's dive right on in here. And so if you look at the world space, you have a huge map. We call it the world, right? So that's the top level. Think of this as a tree, right? So the world is at the top. And then we have these sectors. So we have a family house maybe at the bottom. And inside that family house, it has a bathroom, kitchen, common room, and bedrooms, right? And so maybe that will break down to an arena, right? And then you have what are known as game objects. So those are things like bookshelves and tables. So this is a way of just ordering the hierarchy of what's going on in here. Now remember, we're using LLMs here, and we're using Python code. And this is all visual stuff. So the question is, how do we convert from the visuals that we understand into a simulation that we can process? And so all these trees and the way the information is sorted and all those things will become much more important as we move through this. But for now, just understand that we have a tree to represent all the things that are going on in the world. Now, there were two key components in this paper that really set things apart. So number one was the simulation, okay? And the idea, if you look at this simulation here, you have someone there, her initials are IR. That's Isabella Rodriguez. She's sort of like a Dolores, if you ever watch Westworld, right, of this particular world. She's kind of the first, and she's always one of the original three that were put in the simulations. They started with three and then spread out. And you can see all these things going on around Isabella. You have somebody sitting at the counter who's smiling with a cup of coffee. You have two people chatting, KM and ML. They are chatting. You see the little chat icons. And then you have someone, GR, who's down playing music and happy down by where the piano is. And so these are all events that are happening, going on around Isabella. And you'll find that she can see a certain amount of events. She can take in a certain amount of things. She understands different things that are going on around her. And so it's a simulation for each individual agent, right? And so each individual agent has a whole process going on that they're keeping track of. So that's something that really kept this apart versus other LLMs like LangChain and everything, which are just procedural, right? They're just abstract layers of code versus an actual simulation in this particular instance, in a top-down 2D world. Now, the other big thing was the long-term and short-term memory tied together. So this allowed for creating a routine for the day, so a plan for the day. And every agent would create a plan for the day and say, oh, I'm going to do this in the morning, I'm going to do that. And just like you would, you usually know kind of what your next day is going to look like. And in a lot of cases, you'll say, okay, I know what my schedule is. Some of you will even look at it the night before. And you have all this kind of laid out and have a general idea. And that's kind of like your long-term plan, so to speak. That's part of your long-term plan. But you have the short-term memory as well. So you can interact with people during the day and maybe something pops up and you're like, oh, I might want to do this. And so you can kind of rearrange stuff a little bit. And so these two components, the long-term and short-term memory working together, and there's a process called reflection, which we'll talk about, which kind of ties it all together. It was a new and ingenious way of handling short-term goal setting and long-term goal setting. And how do we keep those together? And so this is the key insight that you had from this, which is this is like a memory stream of the agents. And so every agent during every turn will go through this process. They will perceive something, then they'll access the memory stream, and they will retrieve something from the memory stream. They'll retrieve memories. They'll have these retrieved memories. And then they'll plan. They always plan something, so they'll plan what they're doing next. Now, sometimes they'll do exactly what they were doing before, but sometimes, there's a time change or something else, or somebody shows up, an event happens that was unexpected. That it goes through that plan procedure. And that by itself gave interesting results, but it was when they added this part of reflection when things really went crazy, which was this idea that we can summarize and think about who we are. The agents will actually think about what they've experienced and create a summary of that, a short 1 or 2 line summary, which will kind of help guide them as they grow and change over time. So with the planning and the reflection, they're able to stay on target for longer term goals. And then of course they act, which is known as execute. So let's just briefly go through each of these a little bit more so you can understand what's going on, because this is the key insight and you'll see this a lot in the paper. And once you get this, everything else will make sense. So you start off with what is an agent? Well, we have a character sheet. So I don't want to make any presuppositions about the people who are attending this talk, but there's a good chance a lot of you played Dungeons and Dragons or some other kind of RPG game when you were growing up. And, we always had a character sheet, right? A character sheet. And in D&D, you would have, strength, dexterity, maybe proficiencies, spells, et cetera, et cetera. And it's just a thing that you kept track of who you were as you went through the gaming environment. And so it's very similar here. So we have a character sheet, the agent. We have things known as vision and attention bandwidth at the top, and retention. So these things are all important, and I'm just going to mention them because the attention bandwidth, for instance, you may not be able to take in more than 5 things going on around you at one time, right? Humans, we have this thing called a reticular activating function, which means you're able to block out a lot of the things that go on around you so that you can focus. And people with ADHD have problems with their reticular activating function, right? And so that's why the attention bandwidth, the more things that you can focus on at one time, maybe allows for you to experience more at the same time. Likewise, things like retention and the vision might be, okay, well, how many things can I remember at one time? And how far is my vision? Like, these are all things that happen that we can check later on. And so this is just an example, and you see their daily requirements. These are things for this individual who is really important to them that they accomplish throughout the day. So these are like the key points, right, that they'll have. So it's very important that they open the cafe at 8 a.m. Like, just like whatever time you're starting your work or whatever project or whatever, you're like, I got to be there at a certain time. Boom. And so you have that set. And these agents also have those things set. There's a lot more into it, and we'll take a look at one of those at a sample. But you're more than welcome to dive through. This is Isabella Rodriguez again, age 34, and that's her character sheet. Okay, so let's go through the process here. So the first thing that you have is a perception. You got to perceive everything that's going on around you. And the one thing that is different here than maybe what I've spoken about before is you'll notice that there's a refrigerator that you can see there. There's a sink. There's some pots and pans in the behind where Isabella is. And Isabella will perceive those every turn. She'll say, okay, the fridge is still empty. The sink has dirty dishes in it. The pans are still there. These chairs are empty. Like, these are all things that she'll perceive in her environment. And, certain things will have more importance. So 2 people chatting in front of her will have a different importance to her that she'll allot. And the person playing music, the person that she's serving, will have more importance because they are closer to her and they have a previous interaction. And the other thing is these little icons you see here. These are they call them pronuncios. It's just a short way of expressing an action in 2 emojis. And they send it off to ChatGPT. When we go through, we'll show you how they do that. And they get these emojis returned. So you can do like an emoji conversation in the ChatGPT. And so these are the ones that get returned to express what that process is. And it's just a visual for you to kind of understand what's going on. All right. And then we have a memory stream. And a memory stream is a catalog of everything that's going on. And so it can get pretty big pretty fast. So, for instance, it's basically just a JSON object, our collection, right? And so you just stack objects on top of each other. And it gets bigger and bigger. You can get 400, 500, 600 objects that get added in a day. And so, as you can imagine, the more the simulation goes on, the more difficult it becomes to parse that kind of information. But you do have a memory stream of everything that goes on. And then what we do is we retrieve from that stream and say, okay, this is what's important right now to me. And so there's things known as recency, importance, and we get this something called a poignancy score. And so what happens is we might ask a question in the code, right? What are you looking forward to the most right now? Because we have to make a decision about, what to do next. Maybe we're scheduling the day while Isabella is sleeping. And one of the things in her character sheet is Isabella is excited to be planning a Valentine's Day party at Hobbs Cafe on February 14th from 5 p.m. and is eager to invite everyone to attend the party. So she's one of those extroverted people talking about her party nonstop, right? Can't wait to run into those individuals. Well, then she has, you feed this in and you get an idea of different tasks that she could do: ordering decorations for the party, researching ideas for the party, right? These are the things that come out at the top of this list of things that she could do. So we asked ChatGPT what could she be doing, based upon the events and environment, and it'll come out with this list and it'll give you a relevance score. And what happens is she can summarize it and say, I'm looking forward to the Valentine's Day party that I'm planning at Hobbs Cafe, and take the appropriate action. Okay, that's what's kind of happening in this step here. The retrieve and the retrieve memories. So we're kind of sorting out the memories that are most important. And then we pass it on to the planning. Now, planning is the main cognitive function. This is where the agent decides what to do in the long term and in the short term. It's based on memories, daily scheduling, and, as Bob Ross says, happy accidents, right? So things that might pop up during the day, maybe we run into somebody, out on the road, et cetera, et cetera. And so these are all things that we'll talk much more about the planning in a little bit. But the reflection here is where it separates itself from the other tools. So let's take a look at Klaus. And he's one of the other three main characters that you'll have in here. Now, they have these observations. These are previous memories that have happened. And so Klaus has a lot of memories. He's making a connection between articles. He's at a library table being used to research material. He's reading the assigned material. He's using a library table to discuss research material. He's discussing his research with a librarian. He's engaging with the librarian, right? So these are all like things that have happened in the past. And so Klaus can look through those during a reflection period and kind of filter them up. Where Klaus is dedicated to research, he's engaging in research activities, and he's dedicated to research, right? So these are kind of like abstracted up into one layer. And then we get a final reflection, which is Klaus Mueller is highly dedicated to research. And so this becomes part of Klaus Mueller's identity, his character sheet. And these reflections, just like humans, don't happen all the time. They happen intermittently. So there's a certain threshold. So you could actually create a character that doesn't reflect very much at all. We know those people in life. They just seem to go, 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 and they never really reflect on anything. And so you can create interesting identities with these agents as well. So if you're creating someone who's more of a creative kind of person, maybe that person does reflect more often than they would a normal individual, because they're thinking about things that go on in the world and being more imaginative and creative. Right, that's what we call an open trait personality. And then, of course, we have execute, which is we take the current plan and we just execute the instructions. And these computers are really good, right? They always do whatever we tell them. Even when they do the wrong thing, it's because we told them to do the wrong thing. But this represents the end of the cycle. And the next step is perception. So we completed one full cycle. And what will happen is, when they did the paper, they did this for 25 agents. And so they'll go through and do each agent individually, right? So it's a synchronous procedure. But we did get emergent behavior, and this was a fascinating one, what everyone lost their mind over, which was they're planning a Valentine's Day party at Hobbs Cafe, right? We talked about Isabella. She told these people, and then some of these people told other people. And then the fascinating thing is that everybody in this simulation showed up at Hobbs Cafe on February 14th at 5 o'clock to experience this party. It was an emergent behavior. They created this challenge, this issue on their own, and then they solved it together, which was a fascinating behavior. They also had people who were running for office and other kinds of things going on in there. I encourage you to read the paper to find out all of that. However, there are some challenges. So one of the challenges that they found was that it was around $7 to $10 a day for 3 personas. So I ran this a lot. It cost me $10 every time I wanted to run this, because there's dozens of API calls per persona per step. even if they're not sleeping, right? So at minimum. So like for instance, when they prepare their day, you have to prepare every hour. So that's 24 calls to ChatGPT just to prepare the schedule for the day, let alone summarizing that schedule and doing other stuff. So we're talking about hundreds and thousands, tens of thousands of calls that go on. So that's just mainly from the architecture. There's probably some ways to clean that up, but there is some cost involved with this. Two is the speed that we have here. So again, 1,000 plus memory nodes per persona per day. It gets saved as a JSON file, which is around 5K. Think about doing this for a week, a simulation for a week. 35K JSON file with 7,000 nodes can start to take time to parse, especially for each agent, right? It's not just one, you're talking about each agent. And so these things start to add up. The code is synchronous, so it's not async code. So again, this is another speed challenge that probably, with a little bit more experience on the coding end, could clean it up. And these are some interesting things. So it's too polite and some other social norms. So the language between the agents became kind of formal. So a spouse would wake up and say, "Good morning. Hi, how are you doing today?" And the other spouse would say, "I'm doing very well. Thank you for asking. What do you plan to do today?" Very, very high fluent language, which is, not normal language that you would have in a simulation, a human behavior simulation. And that's because of the LLMs, obviously, and how they're built. So that's something that we may want to look in as we move forward in this kind of technology space. How do we make this more like human behavior, real human behavior? Also, there's social norms that the agents didn't get. So, somebody was going to the bathroom, another person would walk right into the bathroom and stand right next to him and start talking to him and stuff, and other things like that. So this is, okay, you could probably figure out how to close the doors and other things. I mean, this happened because there were stores that were closed, and people would just start walking in and doing stuff in the closed stores. So there's some social norms that are not in the LLMs that would have to be trained into the simulation to be able to kind of figure them out. Now, another fun one was the drinking problem that they talked about, which was there was a bar that opened up in town, and then they were complaining because, by they, I mean the people who designed the simulation, because all of a sudden all their people started showing up at the bar at random points in the day, and they're like, "Why are they showing up at the bar, etc.?" I don't know. If I lived in a simulation like that, I might start having a drinking problem too. And so they kind of shut that one down. But it was interesting that everybody just started showing up at a bar, which I thought was pretty neat behavior. Okay, so what about the code? So, I'm always one of those people who I code to get things working first, and I don't care how sloppy it is. I want working code. And then I'll come back to optimize, and within reason, right? I mean, but you almost always want to get working code first. Well, you got to remember that this kind of code was made by a group of academics mostly. And so their code in spots is actually really good, like especially where they're doing, scientific work and stuff. But their overall architecture and some other things, like there was no debugging really. There was no logging. There was no things that we would find in a normal development environment. So I did fork this repo, just so you know, and I will make it publicly available through BestieBot, and people can just look at it. It has logging. Just be careful. If you run the simulations, it'll log about 200 megabytes of logging data per day. So it builds up pretty fast. Okay. So let's look at how this is structured a little bit. So we have a massive class object, which is the persona. Okay, so we have a server file, which is our main function in Python, right? So it's just your if name equals main, right? And that's kind of the Reverie file, reverie.py. And that is the main server function, and it'll call persona. It'll instantiate the persona class. And the persona will have a move to it. and it'll run the persona.move for each of these individuals, or excuse me, agents. And within this setup, they will have a cognitive folder, which I'll show you, and the perceive, plan, retrieve, reflect, and act are each their own script file. They're not a class. They're just a list of methods. And it's actually good coding practice. So they separated out all of these into like a perceive.py, plan.py, retrieve.py. And so we can go through and look at all of those. So this does match up. So if you're thinking about building your own paper, writing your own paper, it's good to do this so people can easily follow along. And then the memory stream and their retrieved memories are JSON files. So those are helpful. Okay, so let's take a look actually at a simulation real quick, and I think we can take a quick break to answer some questions. If there are any questions that come in, but let's look at one of the simulations in action and just kind of follow it. And yeah, so give me 1 second here. Let's bring one of those up. There we go. All right, so this one just finished. Let's start it up again. Okay, so here's Isabella Rodriguez. You can see she is sleeping right now. Here's the timing. It's Monday, February 13th, and here's the time. 6:04. Oh, there she is. She woke up. And there she is moving around. And she's starting her morning routine, which is brushing her teeth. If we check out Isabella Rodriguez here, we can click on her, which centers it on her as an individual. And it says, waking up and completing her morning routine. Where is she located? We can look at the state details. So if we look at this, we can look at her information, current tile, all of her stats, vision radius, et cetera, her personality, right? So we give these, remember, this is their D&D character sheet. So they have personality and lifestyle. It's called ISS information, the current action state, her daily requirements that she has to do and what her schedule is, right? So all these things, this is our character sheet. I'll list it out. It's down to every 5 minutes. They actually have it scheduled for 5 minutes. And then here's her memory, right? Everything is built down here. This was, at this time when we were running this, it was 1,049 mode. And this was in 1 day, right? So in 1 day, from getting up at 6 a.m. till she went to bed at 10:58, she collected 1,049 memory nodes. Okay, so let's go back and close this. And you can see other people are starting to get up and move around. Let's see what's going on here. Let's check out JM. Who's that? There's JM. We see JM moving around, pick some flowers, right? Here's SM, who's out looking at the landscaping, I guess. So anyway, so all these individuals are going to be moving around and running around the simulation for now. Do we have any questions you want to hit up here real quick? We're watching the sim.
There's nothing at the moment, so yeah,
Okay.
If you want to move on for now, but everyone, don't forget to put your questions in the Q&A tab at the bottom.
Okay, awesome. Great. So again, I'm just going to let the simulation run. It'll run until 8 o'clock. It was already pre-built, so this is kind of running all their stuff. All right.
We do have one question.
So let's. Oh, okay.
I'll interrupt you quickly. So the question is there a concept of memory cleanup in this, i.e. deleting memories at some point?
Not exactly. Like the memories will always stay in there. But there is a relevance score. And so a lot of memories will end up having a relevance of 1 or 0. And it's meant to reflect your experience. So for instance, during the day, if you had gotten into a car accident or, broke up with, like something bad happened to you, that would be something that would have a lot more relevance than, your coffee was cold that morning or something. And so certain memories will just get relegated to a 1 relevance over time. You probably could clean up those memories over time, but then you would lose some of the long-term memories. So maybe you haven't spoken to Klaus, in a week, but you want to be able to still recall that memory with previous memory with Klaus. The question is, how do you sort and sift through those memories?
Perfect. There is another one. Does the relevance increase in some function of how many times the memory is retrieved?
Let me think for a second. It's not, no, it's not done by how often it's retrieved. It can get assigned a different score for other reasons that the LLM might have. Maybe it's relevant to one of the goals that the agent may have. And so if it becomes more important to the goals, and the LLM can decide that when it's creating the schedule, then it will get an improved score. But it does not do that right now based upon how many times it's pulled from the memory. That's not a bad idea. I mean, that's something worth adding, probably.
Perfect. That's all for now.
Okay, awesome. All right, well, let's dive in a little bit to some of the code. The code. All right, let's see what we got here. Okay, so first things first. Let me tell you, on the left here, I did a log breakdown. So I went through a 200 megabyte log file so you didn't have to. And what I did is I basically took it down from initialization in one step. And it's a 7-page text file. I can make it available to anyone who wants to read it and go through it. Again, I did the best I could to show everything that happens in here. And so let me show you a little bit about it. I'm going to dive in, and if you have questions, just throw them in the Q&A as we go through. So first of all, there's a front end and a back end server. Front end server is I forget what it's honestly, I forget the name of the application that they're using, but they have a Phaser, I think it's called, and it's a version of Phaser. And then you have a backend server that's obviously written all in Python. We'll look at it. Now, the Python code here really isn't heavily involved in processing a lot. It's really just, getting things prepped to send to the LLMs, processing it, or, handling it, and, passing it on to this LLM or passing it back to the front end server. So there's not like a lot of like NumPy action and stuff like that going on here, if that's what you're looking for. But so let's join in here. So we have, if you've ever handled gaming, these are called sprites. And so what'll happen is you have an animation of the person. This is Isabella, and then it's like a little map, and then you just rotate. It's like a little window you pull over to animate the little person here. So you have these sprite maps for the characters, and now the question is, how do we get this visual representation into Python? So we have a maze, right? So let's look at it. Oh gosh, what is this? This is a massive NumPy array. And it's just basically, it's essentially a 2D array mapping of everything that's in there. And so you'll see these numbers in there. And so what we have is we have a blocks, which we keep track of. So remember, we had the world at the top. And then I believe we broke it down into sector. So then we have the individual's information here, which is, let me get rid of this here. The Ville is the world, and then we have, their apartment, the cafe. Here's Hobbs Cafe, which we talked about, different people's houses, etc. Then the arena, which is, okay, well, for Hobbs Cafe, there's a cafe part there, right? Isabella's apartment has a main space and a main room and a bathroom, right? So we break it down into little rooms, and then we have game objects, which can exist in any room. And each one of these, as you can see, has an identifier number to it. And so when we look in here and we look at the arena maze, we can say, okay, 32,191. What the heck? Actually, let's look at 161. And maybe we'll get lucky. What is it? Oh, there it is. That's the Rose and Crown pub. That's the pub. So that's a marker there of the pub in the representation of the matrix. And so I know everybody wants to hop into the LLMs and do all that cool stuff. I'm telling you, I've done this. It probably took a week of hard work to create this stupid little NumPy array representation of a 2D world. And you could probably use an LLM to help you with it today, but it is difficult. You got to set all that up because that's your data, right? That's your data for your Python work. And then you have, your visuals for all of your map assets and all those things. We're not going to touch on them, but you have all your visual stuff there. Okay, so let's look at then our backend server. So the first thing we start at, let's look at Reverie. This is our main function. And I'm not going to dive in too much, but this is the start of the step. So a lot of this was added, which was nice. This is in here so you could follow it. And a lot of this is all initialization, right? Let's load our environment based on load. Let's clean up our game objects. Let's get everything ready. And then we're going to go through each persona. We're going to get their current tile that they're in, right? Get the self persona tile, whatever name there are. And then let's see here. We'll go through each persona, get their tile, where they were, where they want to be. Okay, we're with a new tile. We actually move them on here. So let's remove subject and events from tile. So we got to go through and where is the move? Oh, this is all happening from the previous turn, right? So it starts from the previous turn. So they're moving all of them in there. And then they're going to go in here. So this is all like, where were they before? What's the new tile that they need to move to, et cetera, et cetera. Then here, this is the for persona and the persona items. Let's go through and actually calculate the move for this turn. Okay. And so it's actually, we pass in the entire maze, all the personas, the tile that they're on, the current time, all that just gets passed into this massive class where it's instantiated, and we look at the persona. So here's the persona. Let's go back to persona.move. This is the main cognitive function. So that's how we get here from Reverie, right? If it's a new day, we got to figure out if it's a new day or not. Because if it's a brand new day, we got to plan our whole schedule starting in the morning, right? Ugh. And then you'll see here, we get a current time. Here's where we have perceive, retrieve, plan, reflect, execute. They make it look so easy in Python, right? So each one of these scripts, we just call them and we pass in the previous step, essentially. And a little bit of information. So let's look at this. So we have self.perceive, which is just sending us, it's a wrapper that sends us to here. And let's load it up. I was going through this one. Okay. So if we go over here, you can look at this. So generic step, this was the Reverie. So this will cover all those different steps that I talked about earlier, what they're doing for each person. We're syncing the back-end location to the front-end location, all that stuff. And then we're going through and doing the move. So here's the perceive function. So we take the current event and return events that are happening around the persona. So this is the first thing that we have to do. And so we get a calculation of all the things that are going on around this person, like Isabella in this example. And then we embed all that information, right? So first of all, we perceive all these events that are happening around her. And based upon her vision or her attention, we can filter that out. So here's where we find all those events. We look through all the nearby tiles. And this is what's called a perception space. Or that's what I call it. But they call it perceived events list, right? So they have this perceived events list. And then right here is where they go through, they sorted it, and then they say, okay, and then filter it from the beginning to however long the attention bandwidth is. So the attention bandwidth, remember this was the attention. She can only focus on 8 things at one time. So go through, create all those things around her within her vision scope, and then filter down to those 8 events. And then we store those. Now, this is something that's becomes really important. So there's this idea of SPO and description. This stands for subject, predicate, object, and a description. So why does that matter? Okay, so we've gone through, let's just finish this up here real quick, and then we're going to take a quick look at how this information gets stored, which will make things more clear. So we have a subject, predicate, and object, and a description for all these events. We get the latest events, and we go through each one. We do what's known as getting an embedding. So these are, I don't know how many people here are familiar with LLMs, but one of the things that we do is we send this off using the ChatGPT OpenAI API, and we get what's known as an embedding based upon a phrase or some data, and that'll be a numerical representation of what's of this phrase or whatever that we're going to be using later on. And we use this to calculate similarities and importances of things. And so that's what these embeddings are for. So we're saving them later on so that we can filter them saying, this event is more important than another event. And so it's important to manage embeddings. So you're going to hear a lot about that if you work in Python, and LLMs. Embeddings are a way to, it's a different kind of data structure, essentially. If you think of it that way, it's an easy way to understand it. And then if someone's chatting, then we have a little special thing that we go on here where we add the chat, and then we return all those events. So we basically just perceived everything and returned all that. Let's take a look at it. Okay. So here's what we have. So this is an example node here. Let's see, here's 912 to 911. There we go. So that's the node. Let me move this quick. So we have the type count. This particular one is a thought. This is when it created. It's supposed to have an expiration, which looks to be a month. So at least for the thought, it has an expiration. Other things like events do not have expiration. Okay, so it looks like that person who previously asked that question, certain types of events do get have an expiration date on there, but I have not seen any kind of like garbage collection or anything on those particular things. Okay, and then we have the object is Elizabeth Rodriguez, plan Tuesday, February 14th. This is plan for Tuesday, February 14th. This is our whole plan. The embedding key is let's take this embedding key. Boy, that's a long embedding key. Okay, let's just copy that for later. A poignancy, how important it is. Keywords, and anything, and if there was filling. So I don't remember what filling is exactly off the top of my head, but all these other ones we'll take a look at. So this was a type thought. Now there are different kinds of types. So for instance, this one was a type event. And this particular event was the apartment main room bed be used. Okay, so the description is the bed is being used. That was the subject, predicate, object. And that's something that she perceived. It was being used by her, but that's something that was perceived in the environment and gets its own embedding. And so these are, there's tons of types of different kinds of these. So let's look at, real quick, let's look at a type chat. Here we go, type chat. Node count 812 was a type chat. All right, so I'm not going to highlight the whole thing, but you can see here, it was a chat with Maria Lopez. In the description, they were conversing about the decorations and preparations for the Valentine's Day party. We have an embedding key, and then the keywords, and then the filling, which was their conversation. Okay, right. So filling handles where the chat conversations go. And so you see Isabella Rodriguez said, hey, Maria, I wanted to talk to you about the decorations, so on and so forth. And that's their back and forth that they have for their conversation. The entire conversation gets logged into the memory. Okay, so let's look at the embedding real quick. Again, this is crazy embedding. So this is what an embedding is. Isabella Rodriguez's idol comes out to all these numbers, right? It makes no sense. So here's that one that I copied earlier. This is her plan for Tuesday, February 14th, blah, 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 blah. Here's the numerical representation. So if I need to compare that or do some kind of poignancy or any kind of like comparison here with like a cosine similarity, this is why I'll want the embedding, so I can do that here to handle the filtering. All right. And then, and here's her scratch file, which was her agent information. And you can see this is all the information we talked about earlier, including her ISS or her style traits, things about personality traits, daily requirements, her schedule in hour increments, and her schedule in 5-minute increments. All right, we're running out of time here. So let me just dive a little bit into, we did perceive. Let's go into plan, because this is the big one. And so, and essentially what's happening is that you have to plan your whole routine and schedule. But let me show you what happens here. If I go to the, where's the should react? Let's go to create reaction. Nope. Here we are on line 1180. All right, so that tells you a little bit about the kind of Python code that we're dealing with here in this script. We have these events, and we have to decide whether we want to react to something that's going on. Should we react? If we're having a chat with someone, etc. Let's make these plans, long-term planning. Well, all these things are sending to ChatGPT, and you may have questions about, well, how does it interact with ChatGPT? Well, we call this run GPT prompt. And there's always going to be things that it's going to ask ChatGPT, like running a schedule. Well, here's what you have. You have these templates that are built. Daily planning, version 6. Daily planning, version 5. So what happens is you create these variables, like you pass in all the variables in the Python method, and they're in order, right? So this would have 12 parameters that pass into the variable or into the method. And that gets these, call this script, and then it'll go through, it'll identify all these, it'll get rid of this comment blocker, and then pass that into this information here and all this. And this is the script that gets passed to ChatGPT. And there's a little bit of templating script that gets passed to every single call, right? So there's always like a little header script that you get. But this is the dynamic script that always gets sent to ChatGPT. And so this is where a lot of the conversation happens with the LLM. And so all these get built out. So you may think that there's like all these dynamic things going on in the background, but you actually have to take into account every single action that could happen and then create a template for it and then allow the agents to operate within those constraints. So daily scheduling, daily planning. Oh, here's the daily scheduling one. It says it wants it to come back in this format as an array, and here's all the information about them. Create a daily schedule for them based upon this information. And that's what gets passed to ChatGPT. And then having a chat, whether they should decide to talk to someone. Should they decide to talk? Given the context, determine whether a subject will initiate a conversation with another, right? So that the two people connect. There's code that says, should these people talk? Well, send that off to ChatGPT to figure out whether they should talk. So one of the things that you got to start understanding, and I don't know what people's backgrounds and stuff are, but LLMs are starting to become a part of the pipeline as a reasoning agent. Should I do this? Should I not do this? How would someone react? Et cetera, et cetera. Those kind of things get passed off to the LLMs. It's sort of like instructions almost to a CPU, and they spit them back. But it's more, they're not quite so imperative. It's more functional, right? So in this case, it's a little bit different, right? So we have these paradigms where you would have imperative programming, X, Y equals blah, blah, blah. And you like to do step by step. That's what like assembly is, like very imperative programming. And then you have functional program, which is like mapping, reducing, list comprehension, stuff like that. Things that, map data or transition data in a way that it's not as constrained by every step. You just give it a goal and kind of like, pass it the data. Well, LLMs are kind of the next step of that. It's LLM coding. And so you can send this information off and get this experiential information back. So that's why all these things are in here. And I'm not going to go through all of them. Again, we're out of time on some of this, but here's like, for instance, doing a cosine similarity of A and B, which are embeddings, two input vectors, right? That's where they do the retrievals. So when they're doing the retrievals, they decide, should I retrieve this memory, which has this much importance? Maybe I should compare it to that one. So that's how things get retrieved. They do a comparison. And then let's see, there was retrieved. What was reflection? Let's just look at that one real quick. So if we look at reflection, so it says if reflection trigger persona. So if the person, if they're, let's see here, let's look at their score. Let's look at Scratch for Isabella. What is her importance trigger? Max is 150, current is 122. So if this went into that reflection trigger method, she wouldn't have a reflection yet because it wasn't important to her at that point, right? And that variable changes over time. So again, the reflection, it says, do you have this? Should we have a reflection? If it does, then it goes through and does this process. And again, look at this. Print kaboom. This is literally in their repo that they had here. So this gives you an idea. Init planning, blah 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 blah. Right. So this was definitely not production ready code. A lot of research code isn't that comes out to you. So you just kind of have to roll with it and see what you get. So again, and then if it goes through this whole thing, it goes through this planning thought. It'll go through and send it off to generate action event triple, which is, sending it off to ChatGPT. It'll get information back as a subject predicate object. It'll create an embedding from it, and then it'll add that to the thoughts. So again, I got 5 minutes left. So I know that, some of the Python code, I didn't get a chance to dive in too deep in, but I'm happy to answer any kind of questions that you have about the code itself, and go from there. So, yeah.
Yeah, we do have one question. Is there a formula that determines the relevancy of a memory? Is it associated with the persona's traits? And if not, are the values selected by one specific developer to keep them consistent?
A formula. Well, how do I phrase this? So it's kind of the formula is they ask the LLM in a lot of ways, and they pass it the scores that it has. So let's see here. I'm pretty sure. Let's take a look. Summarize chat ideas, task decomposition. Let's see if there's anything in here. Daily planning. Poignancy event. There we go. Okay. So, right. So you have this idea in the question of creating a formula for something. And what's happening instead now is that we're passing the parameters to the LLM and allowing it to make that calculation for us. So for instance, we pass it the agent name, the ISS, the name of the event description. And it says, and here's what we pass to the LLM. On the scale of 1 to 10, where 1 is purely mundane and 10 is extremely poignant, rate the likely poignancy of the following event. So that's how we do the rating for these memories. And then it returns this number between 1 and 10. And it will run those events, and it'll run those. Let's see here. Where do we have poignancy event? Let's see if we can find it. Poignancy event. So we're running it from here in this particular template, which is called, let's see if we can I'm just trying to backtrace this a little bit. Okay, so there's in reflection and perception. Let's look at here. Generate a poignancy score. Let's see if we can track that down. Okay, thought poignancy. So, okay, so it looks like we have one there. Probably in okay, so we call it in a reflection. So we'll get the poignancy in a reflection, where obviously we need, is this reflection important or not important? Okay, that's an understanding one. We do it in the conversing. So like when there's a chat going on, is this particular train of thought? Let's see here. Let's look at it in the converse. Like if you're going back and forth with someone, oh no, this particular one, the poignancy score is on the whisper, which is God mode. So that means you can talk to the agents during the middle of the simulation and give them an idea. That's what this particular poignancy score is. So you have to manually assign that. So it looks like it's only in this particular instance, it's running the reflection and the perception at the very beginning, where we're looking at all events that surround an individual. That's when it first gets called. So I'm not sure that there's like a formula per se that's going to change it over time. Again, it just gets passed kind of to the LLM to figure out, it looks like. Not saying that your idea won't make it better. There's definitely room for improvement here.
Perfect. Do you have another one? When two or more personas are within each other's perception space, how is the order of operations determined? I.e., if persona 1 takes an action, will persona 2's next action take that into account, or do persona 1 and 2 actions execute simultaneously?
That's a good question. I'm pretty sure it's synchronous, not async. So I think it's going to have to be one after the other. Let's take a look though at the Reverie. Let's go down to the bottom of this one. Oh, open server. No, that's an interactive server. We don't want the interactive server. Okay, here we go. Going through each persona. Okay, so let's look at the. Okay, so here is, close this up. All right, so we go through and we essentially make the moving plans for everybody. Everybody gets their plans moved. Then the next, okay, so then what's going to happen is, yeah, up here where you're going to actually make everybody move, that's in this step here. It's a for loop. So it looks like it's going to go through each agent individually and then run that individually. So it's not going to do it async in any way. It's going to happen separately for each individual, synchronously. That's what this loop is. This is the actual movements, and these are all the planning of those movements. Take a look here. Make sure. Where's execute? Yeah. So this the execute here, given a plan, we execute the plan, and it outputs the tile coordinate path and the next coordinate for the persona. Right. So that gets passed into the next step. Okay, where am I supposed to be going? Now, let's see here. Executing persona interaction. So it's a good question if two individuals do not want to talk to each other. Like one wants to talk to the other one person, the other doesn't. Like, would they run away from each other? There hasn't been a lot of conversation about that, so I'm not sure how that would work. It'd be interesting to see. I haven't really tracked that. Most people have always wanted to talk to each other if they get into a range and they have aligning goals. So. Okay.
Perfect.
Awesome.
That's that's all the questions. So, has you got any final words to add? I think we can wrap up.
Well, I do want to say that this technology, I know, seems kind of people are wondering, well, what's so special about it? Most of the people at places like Tesla, X, Microsoft, OpenAI, like everybody's looking at how to create these individual agents. Like Jarvis, this is the idea of how do we create a Jarvis. And a lot of people believe these style simulations with these agents acting in swarm behaviors are the answer to that. And so you're going to hear a lot more about this technology in 2024. We're just scraping the surface here, really. And it was cute to put into a little game and to, simulate all of these things. And you can do a lot of fun things with this already. But I think understanding how an LLM fits into a computation pipeline like this, and how we ask it questions, and how we treat it as just another part of the stack, is a very important topic for 2024 moving forward. So I hope everybody got something out of there, and I've really been excited to share this with people, and I look forward to talking to anybody who wants to talk further about this out there somewhere.
Perfect. Well, thank you so much for your time, Richard. I think a favorite part of mine was the fact that the pub was called the Rose and Crown. That name holds a lot of special memories in my heart. That's my local pub back in the UK. I felt like I must have been the human version of Isabella or Klaus or something. So
That's fantastic.
But no, I really, really do appreciate your time. Thank you again for putting together such a fantastic presentation and demonstration. I'm sure a lot of people took a lot away from it today. Thank you to everyone who participated with questions and turned up this evening. If you are interested in learning more about our events moving forwards, please do follow us on LinkedIn. Also follow the live series on LinkedIn, and this session has been recorded today and will be published on our YouTube channel as well. So thank you again so much for everyone for attending, and Richard, thank you so much for your time again. Really appreciate you coming back, and hope to have you back again soon.
All right, thanks everybody.
Perfect. Thank you.